Hello everyone, my name is Rakshita Vishwanath Giri. I am a third year computer science engineering student from Sri Siddheshwar Women's College of Engineering, roll number 346. Today we are going to understand a very powerful and practical concept in machine learning called PAC learning, which stands for probably approximately correct learning. Don't worry, it sounds technical, but we will go step by step using a real life example, which is detecting spam emails. So, introduction to the PAC learning. PAC learning is a framework in machine learning introduced by Leslie Valiant, and it gives us a way to measure how good a algorithm is, especially when it learns from example. And the two keywords here we use is probably with high confidence, for example 95%, and the model is correct. Approximately, the model doesn't have to be perfect, just it have to be close enough to the real answer. In simple words, we can say PAC learning means we can learn a rule that is almost correct and we can be mostly sure about that. And it is used in the spam filters, fraud detection, etc. So, real world scenario, spam email classification. Let's say we want to build a system that can detect whether an email is spam or not. We will train it on a, real email data labeled as spam or not, and the model will learn patterns from those examples. So here are the input data we will use. We create a features from the emails. For example, does the email contain buy now, which is nothing but x1, and discount as x2, hello as x3. And another feature is label spam or not. So here is our data set containing the features like emails x1. X1 is nothing but the buy now, x2 is nothing but the discount, and x3 is nothing but hello, while spam, which is a label spam or not. So here a x1 is 1, while x2 is 0, x3 is 0. It is a spam. B x1 is equal to 0, 1, 0. It is a spam. And C having x1, x2, 0, but x3, 1. So it is not spam. And D x1, x2 are 1, but x3 is 0. So it is a spam. While E x1, x2 both are 0 and x3 is 1, but it is not a spam. So we learned from that hypothesis the observed pattern such as if the email contains buy now, which is x1, email content x1 is 1, then it is a spam. But if x3 is 1, it is not spam, and if x2 is 1, it is a spam. So it forms this rule, h of x is equal to x1 or x2, or we can also say spam is equal to x1 or x2. Understanding the PAC learning terms from that example, the first term is instance space capital X. It is nothing but all possible inputs, for example email features, or we can also say all possible email features combination. The next one, concept a class capital C. It is all valid rules, for example all true spam rules. The real unknown rule, or we can say all correct spam identifying rules. And the target concept, small c, the real unknown rule we want to learn, or what count as a spam. Here hypothesis class capital H, the rule, all the rules the model can choose from. or we can also say that from which feature that model can choose. And hypothesis small h, the rule the model actually learns, or we can say the actual rule which is learned by the model, which we saw at example x1 or x2. And epsilon, next one is epsilon. It allowed error, example 0.05 is equal to 95% accurate. We can also say, which means we allow some mistakes, means 5% mistakes. And delta, confidence level 0.05 is equal to 95% sure of accuracy. Means 5% chances we are wrong and 95% are sure of the chances that we are right. And the next one is sample complexity. It is nothing but the number of example needed to learn with the epsilon and delta, or the number of emails we need to train the model well. Next slide is all about the testing the rule we learned from spam detecting example, testing it on the new email features. For example, these are the features: buy now, hello, and discount having x1, x2, x3, and the prediction spam or not spam. While here x1 is equal to 1, but it is prediction is spam, while hello x3 is 1 and it is not spam. Discount x2 is 1 and it is spam. So all three words x1 is equal to 1, x2 is equal to 1, x3 is equal to 1 is spam. So why PAC learning is useful? We don't need perfection. I mean, we don't need perfect models, just ones that are good enough most of the times. And enough data is good real world results, which is if we collect enough data, our rule will work well in the real world situations. And PAC allows small errors with high confidence. It's okay to have a 5% error as long as we are getting 95% of confidence. And the next slide is all about the conclusion or the revision, that the PAC, which stands for probably, approximately, correct, and learn good enough rules from the examples, work well for spam detection, fraud, and recommendations. And PAC ensures rules are mostly right with enough data. We can learn rules that are almost always right. And model which we learned, that is spam is equal to x1 or x2 with confidence and small error. Thank you for watching.